Hello and welcome to Chapter 3, which is about variables. A way to think about variables are they as a container for data stored within the memory of your machine. In this particular case, when I declare, for instance, dim length as integer, I'm going away, and it should really be int length for our purposes, but I'm going away into memory. I'm finding a place that I'm going to store an integer value, and I'm labeling it length, or int length. I call it int length so it represents the data it contains. Because when we get to the other data types, you'll see that in order to see, you can easily identify what type of data it contains based on the variable value, or the variable name. Dim gives it the dimension. It's a visual basic thing. So let's go to the next one. You can store only one value at a time. So if I dim x as integer, x equals 5, it put a 5 in here. But then when I say x equals 10, it writes over the 5 with a 10. Makes sense? So it can only contain one value at a time, and it's the value that it's declared as. I couldn't put a decimal in here because it's declared as an integer. Input can be in the form of data typed by the user, and usually it's taken in by a text box. You can also have a calculation. I have an example where a calculation is used. There's a text box. We talked about this before. The naming convention of txt is there to tell us, hey, it's a text box. And we also have text alignment, which, hey, you can align your text. Not that thrilling for what we do. Right, so in our case, there's also what's called a val function. What a val function does is it's called typecasting. The machine language does not recognize a string as something that you can calculate. So for instance, if I do the val of 33 with this quotes around it, it doesn't understand that 33 with quotes around it is a number. So what you have to do is you have to convert it to a number so it knows what it is by using this val statement. All the val statement does is it takes in, this val function, takes in whatever in the parentheses and it converts it to a number. Now in our case it would just be 33, so it knows what the heck it was, tied to 33. It's interesting, if I do a val of 62 centimeters, it converts it to 62, which you don't want to play that game because sometimes it'll work and sometimes it'll throw an error. So I wouldn't do that. And then, of course, if I take in information from a text box, information taken in from a text box is always a string, and it does not recognize it as a number. So if I do val me txt height.text, it takes in the val of the height and converts it and puts it over here. Okay. It's going to take in what the user puts in, converts it to an actual integer value, which is awesome. All right. There are different types of variable values that we can use. Integer stores whole numbers, and that's the three-letter int, so I call it int number. Double, numbers with a decimal. So if I was calling something with a decimal, I'd call it dbl number. And then the decimal is currency values, so I would call that dec. And then date, DTE, char, CHR. Char data type runs into some problems sometimes, so try to avoid it. People get kind of confused, but you can try it, but a lot of people solve it by string or using number input, things like that. And string is a set of characters, right? And Boolean, or Boolean, right? True, false, on, off, or yes, no values. Okay. Now, here's what you got to look out for. You're declaring a variable as a data type that's not going to be the data type that's stored. So for instance, dim x is integer. X is an integer, right? But I try to store something with a decimal in it. Well, because I'm trying to store something with a decimal in it, it's not going to store it as a decimal. It's going to round it. So it turns 6.7 to 7. Boo. Okay? So you want to make sure that you don't make those type of truncation or rounding errors depending. Okay? Now, this variable scoping example kind of works, but I kind of made you a better one. I'm going to pull it. Basically what's happened is I've declared this globally, dim x is integer, right after the form 1, meaning that any object in the form is going to be able to have access to that. The issue is, now, before we get too far into it, don't name your variables x, y, and z. Okay? I did that because this is the example and I wanted to go according to that, but I don't like what they did here. But dim x is integer. Now, when I declare another x as integer inside this button 1, what that does is this takes precedence over this declaration. As a result, dim x is integer equals 10, dim y is integer equals 30. So, and dim z as integer, if z equals x plus y, x is 10, y is 30, so z is assigned 40. Now, they don't give you the explanation of what goes on here, but I can tell you that x is 25. Why I can tell you that x is 25? Because dim y as integer equals 5. Dim z is integer. If z is equal to x plus y and z is assigned 30, the only value that this given is 5, which means which means that x has to be 25 because it's not getting a value from anywhere else. But note that if x is declared globally and it's given the value of 25, then anytime x is used in any object, it'll be 25 or whatever it was when it left the last object, except this one. It's kind of a weird concept to understand, but let me try to help you out a little bit with this awesome program that I have created right here to talk about variable scoping. Yes. Okay, now look. This is a local declaration. There's x is 10, which we just talked about, right? So here, x is 10. Okay. Let me move this down here so you can actually see it. So there's our x is 10, right? And our y is equal to 30. Awesome. The only difference is when I declared x as integer, I made it 25 up here. So the first time it runs, x is 25. Now, z equals x plus y. X is declared as 10. Y is declared as 30. This value will be 40 or 10 plus 30. 10 plus 30. And that's what it'll be. Awesome. And I actually put it on a label called z. Well, excuse me, a label answer.text equals z, so you're able to see it. I also did this. I wanted you to see the difference between a local accumulator of that variable x that changes that value at a local level, and I wanted to see you at a global level. So, I said x equals 5 plus the val of x. Well, the val of x is always 10, so if it's 5 plus 10, traditionally that's always been 15. Hopefully that's not news to anybody. And for those of you that are, yes, 5 plus 10 has always been 15. Okay, so I have 5 plus the val of that, that's 10, 15, so x equals 15. And then I put that value in this text box. The value in the label is 15 due to the x variable being declared locally, so it always takes precedence over the global. Now if I scroll down here, got some other stuff going on, so there's our dim y is integer equals 5, dim z is integer. So z equals x plus y, this value will be 30, or 25 plus 5, the first time it's ran. Okay, and that's important. Also note that the value of z will be 0 when we leave the object because it's declared locally. However, if we were to change the value of x, it would retain this value. Going down below, x equals 5 plus the val of x. Notice I'm assigning a new value to x. So each time I'm going to do this, it's going to add 5 to the value, and I'm going to be able to see the change as we go through. The first local declaration will stay 15. This will always go up by 5. It says the value of x will always go up by 5 since it retains the value when the code leaves this object. So let's run it. Oh yeah, it's going to be awesome. Here we go. So here's my local value. It's 15. This is 40, right? Awesome. So let's hit my global. There's 30 and 30. Watch what happens. Goes up by 35. There we go. See my values changing constantly, right? Now, if I go back to my local example, it's 15 and 40, 60 and 60. So what's happening is the local example is still working with 10, 10 plus 30. The global example now is incrementing by 5 every time, so it's retaining the value outside of the object. Very helpful. Just kind of keep aware. Once again, I'll come back, I'll close this, I'll open up the code so you can see the code again, right? Let's just close this window right here. just kind of, so now you're going to take a look at it, just kind of see the value. Notice this is declared locally, so this takes precedence over the global value. This is declared locally. The first time we run this, it's 30 and 30. And then each time it goes up by 5. Boom, 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 boom. Because it's awesome. All right. So there's that part. Let's continue. Right. Integer division truncates a decimal portion of the quotient. Only the inner portion of the quotient is returned. Okay, that's nice math speak. Okay, but that means that if I put in int value equals 20 divided by 7, it's going to return a 2. Okay, so that's going to be my whole number, or my integer division, with the forward slash, right? Well, I guess the camera first. I guess I wanted to be that way. Slash. Like that. Okay. So, named constants. You don't usually use constants very often, but the values don't change in the code. So constant pi is double, right? That's one good example of use of constants. But once you declare something as a constant, you can only use that variable value as it is. You cannot change it. And these are a bunch of keywords. You'll know those and get to know those as we go along. Now we have 3 different types of errors. A syntax error violates the rules of Visual Basic. You didn't write it. You didn't write it down correctly. You didn't code it correctly. There's 3 I's in the word string or something along those lines. Logic error, also called semantic errors, occur in statements that are syntactically correct but produce undesired or unexpected results. This is the 1 + 1 = 3 error. That's what I like to call it. And the runtime errors, also called exceptions, halt the program execution at the statement that cannot be executed. Big words for I push play and it doesn't work. It breaks. Logic errors will work. You just don't have the right results. Syntax error, as I type it, it gives me errors as I go through. So, and you will have the use of the debugger, and this is where you start to get into the debugger and you start to see the values. This is a breakpoint, and I will have an entire different lesson on a breakpoint because it is that important. So look for that in this section. It is very, very important that you learn how to use breakpoint. You can tell people who don't because they have problems with their programs later on, and then you say, did you put a breakpoint in it? And they go, what? I never understood those. Understand what a breakpoint is. Understand what a breakpoint is. Understand what a breakpoint is. Very important. Okay. Right. We're not going to worry about application deployment and code conventions. Variable identifier should be in the lowercase letter. We talked about that. We talked about the 3-letter extensions. You don't have to worry. After group of declarations, make it clear where declarations end. You'll notice as I'm going through, I do my declarations and I go down to where I'm actually coding things. That's what that means. So here's my declarations, down, then I code things. All right, that's what's going on there. Use a descriptive prompt next to text box to tell the user what kind of input is expected. I didn't do that on my example, but if you're going to input the name, put a label in there called input name. All right. Choose data types that are appropriate for the type of data being represented. Declare variables so that the scope is limited to where they are needed. We talked about variable scope. Constant identifiers should be all uppercase. You don't have to worry about that. And we already did the constants. Now, there's one last thing that I'm going to talk about when we did this. Okay? Right here. Modulus division. We skipped it for some reason. Okay. 2, like if I do 20 mod 7, the word mod 7. The other one was our whole number division, which was like that, okay? And that looked like this, and that returned 2. Modulus division will return the remainder. So if I do 20 mod 7, it will return 6. If I do 20 integer division 7, right, it's going to return 2. Mod 7 returns the remainder. This returns the whole number. So this will return 2. This will return 6. Modulus division. Remember it. Integer division. Remember it. Breakpoint. Remember the breakpoint. Know how to use them. As always, if you have any questions, refer to your resources or speak to your sub. Resources, sub, or ask me questions on the bulletin board. The forum. Thank you.